Great. Thanks for having me. My name is Danny Ryan. I work with the Ethereum Foundation on the research team. I spend almost all of my time working on kind of core consensus protocol upgrades. And that project is kind of encapsulated in what we call Eth2. And today I wanted to give you some context on what Eth2 is, what Eth1 is, what these things are in relation to each other, and how they kind of come together to be the future of mainnet. And if you take away one thing from this talk today, it's that the terms Eth1 and the terms Eth2 are a misnomer and imply a false sequentiality. They imply one being deprecated for the other. They imply some sort of migration. They imply something that's not quite accurate. Instead, they represent different layers of the stack, different layers of focus, different layers of optimization and R&D. And I'm going to get in and explain what these two layers are and how the vision of how they will come together in the near future. So Eth1 plus Eth2 is Ethereum. We're talking about the future of mainnet today. So what is Eth1? Eth1 is quite plain and simply the Ethereum we know and love today. Again, if I could erase these terms and use something different, I would. Maybe we'll try to in the future. But Eth1 is Ethereum, warts and all. It is a single blockchain. It is run by a proof of work mechanism. It has tons of DeFi activity, NFT activity, identity protocols, all sorts of really cool stuff. And it's why we're all here. But concretely, we have implementations of this protocol, kind of accesses into this protocol and gateways into this protocol called Eth1 clients. And really, what is an Eth1 client? Obviously, it's an implementation of the protocol, but we'll dig a little bit deeper. For the purposes of this talk, I'm going to view it as its consensus and its user layer. And its consensus is proof of work, which is actually a relatively simple consensus mechanism. That's one of the beauties of proof of work, is that it is indeed simple from an implementation and software perspective. A lot of the complexity of the protocol, randomness, leader election, dealing with the actual economic asset for the crypto economics, that's all handled outside of the protocol in the sophisticated mining hardware. And so you end up with like relatively simple rules and protocol, verify some hashes, add up some difficulties, and find the head of the chain. In addition to what I would argue is a thin consensus protocol and software, is a highly optimized user layer. When you think about all of the hard work that goes into optimizing Ethereum and dealing with the complexities of state and transactions and all of that, that's really in the user layer. And if you go and look at the diff and guess, like there's probably almost been no work done on the proof of work consensus algorithm for years. Go look at it. I haven't looked at it. Probably pretty thin on what's going on there. Whereas all the work is happening on state sync, state management, transaction optimizations, EVM execution. And it's all really like the secret sauce here is how to get that user layer highly optimized. And so I mentioned some of these things. Some of the optimizations you hear people and some of the deep work being done on Eth1 clients or transaction mental management. There's riddled with security issues when people can send random transactions to you, DOS vectors, all sorts of stuff. Transaction gossip optimizations to optimize bandwidth consumption, efficient EVM state transitions and state accesses, state rights, read and writes, and a big one is state sync. The active state in Ethereum, quite large. And so managing that from how do you get it, how do you share it, how do you store it, a lot of effort goes into these types of things. This is a extremely oversimplified diagram that I threw together of an Eth1 client. You have the P2P network where you're communicating with peers and sharing information about the protocol, transactions, blocks, state sync. And you have this proof of work consensus, which is at the top, because it's kind of the brain. It's ultimately deciding what should be done at any given time with respect to finding the canonical chain, which blocks should be included and viewed as canonical, how should it manipulate the state with respect to that, and if you were producing blocks, if you're a miner, how to go about that. And then you have everything else, and everything else is a lot. And everything else is, again, where a lot of the hard work is done. Managing the EVM, state transitions, managing the complex state and the state tree, managing the mempool and all the complexities that come with that. And so that's an Eth1 client. And the bulk of the work is not in that proof of work component. A little side tangent, what do we mean when we talk about Eth1X? Eth1X is generally a group of people on the internet, like all these things, we're just random people on the internet, focusing on R&D on the user layer. So all those things, it's not an upgrade of that proof of work. Instead, it's really all those other things. How do we manage state? How do we manage transactions and execution? And how can we make it more sustainable? And how can we make it a better experience for Ethereum and the community? So that's 1X, focusing on that layer. To mention some of the things going on here, they're looking at upgrading the state trie from this hexary trie to a binary trie for some efficiency gains. Stateless block processing as a method for managing the complexities of having a large and growing state, so that we can have spectrums of different types of clients interacting in the network that don't necessarily have to have all of the state. Account abstraction to increase, open up some like interesting types of applications, and some of the stuff I'm really excited about is some of the security implications of having account abstraction, being able to do tornado cash and that kind of stuff in a more secure fashion. Gas fee reform, 1559, improving the UX of getting transactions included, improving some of the security concerns around minor extractable value. Again, all in this user layer. So that's Eth1 clients. Any questions? No, I'm sure. Eth2. What is Eth2? We talked about Eth1. What do we mean when we say Eth2? Really, what Eth2 is a radical upgrade to the consensus layer of Ethereum. When you look at all of the research for the past 5 years that has culminated into this Eth2 project, all of the work going on in Eth2 clients, and all of the work in this layer and in the subsection of the Ethereum project is on consensus upgrades. Can we upgrade to a more secure, more sustainable, and more scalable consensus mechanism? And that's what we mean by Eth2. And so again, different layers, different separation of concern, false sequentiality, bad terms. Eth1, Eth2, bad terms, maybe they're here to stay, but let's start thinking about them more as layers of the stack. So it's ultimately, this is back to that crappy diagram of an Eth1 client. It's looking at that proof of work consensus mechanism and it's saying, can we do better? Again, can we make it more secure? Can we make it more sustainable? And can we make it more scalable? Past 5 years of research say a resounding yes. I just wanted to include this image because I thought it was pretty cool. Pretty worthless slide other than that, but great to say. Yes, so the plan is to move to a proof of stake and sharded system, sharded consensus mechanism, and I'll talk to you a little bit about what that looks like. So what then is an Eth2 client? We have this piece of software called an Eth1 client, highly optimized user layer. So what is an Eth2 client? Really it is, it doesn't touch any of that user layer stuff. It's really looking at that brain, what was that proof of work brain, and it's swapping it for building out a proof of stake and sharded consensus. Like I said, proof of work, we get a lot of stuff for free because it's handled in extra protocol complexity. Whereas with proof of stake and a sharded consensus mechanism, there's a lot of in protocol, a lot of software complexity to make that work. And so all of the work that's gone on in Eth2 clients in the past 2 years is to solve that problem, is to handle and manage the complexity of a proof of stake and sharded consensus mechanism. To zoom in into that brain right there, we solved that problem, or solving that problem, through the introduction of a system level chain called the beacon chain that manages validators, manages the core consensus, manages the system level state called the beacon state, has its own P2P layer where it essentially manages gossip and communication of system level, consensus level items such as beacon blocks, attestations, validator exits, that kind of stuff, and ultimately is the brain for the consensus of, rather than just one chain, my cat of course is here, rather than just one chain, Eth1 as we know and love today, managing the complexity and consensus of multiple chains. And then we call them shard chains. So that's what an Eth2 client is. It doesn't touch the user layer. It's coming to consensus on, it's a sophisticated mechanism to come to consensus on things. And obviously the stuff that we want to come to consensus on is things that are valuable to users and valuable to the user layer. But it is more of just a general mechanism to come to consensus. So then, like I mentioned, one of the things we want to come to consensus on is Eth1, is the Ethereum chain that we have today. And so the plan is to hot swap the consensus of Eth1 at a point in the future with the consensus, that proof of work consensus, with the consensus of an Eth2 client, with that proof of stake sharded consensus. So I've kind of implied and alluded to the fact of where we're going, but we have all this incredible work that's done in Eth1 and on Eth1 clients. Geth is a machine. Like there's awesome stuff going on. Nethermind, badass stuff going on. All these clients, lots of great work going on in that user layer. And then in Eth2, we have incredible work going on in this consensus layer. And so the future of the Ethereum stack from a node perspective is really the unification of these two pieces of software into a beautiful, cohesive combination that each piece of software handles the sophistication of its designated layer. So let's drill into this image and take a look at what that actually is going to look like. In the prototypes of this merge that we've been working on, this looks like an Eth2 client and an Eth1 client, or as we might call it in the future, an Eth1 engine, running on the same computer, connected via RPC. So that Eth1 engine, that's that Eth1 client diagram that we had earlier. Instead of the little proof of work brain, it's opened up its consensus to be controlled via RPC, to be controlled via a remote protocol. Now the Eth2 client's running in parallel to this Eth1 client, and it's coming to consensus on things. It's driving. It's building that system level chain. It's building the shard chains, and it's communicating to its local Eth1 client the state of things from a system level perspective, being like, here is a new block, rather than the proof of work saying here's a new block. It's saying here's the new block. Oh, there's actually been a minor reorg. Here, update your internal state. This is the new head. And really that Eth2 client becomes the driver, becomes the brain, whereas the Eth1 client handles all of the user layer complexities, transactions, state sync, all that kind of stuff. This quick zoom in, these are just the two diagrams of the Eth2 client controlling to the Eth1 engine via this RPC and getting responses. Sending requests, getting responses. It's a unidirectional protocol, the Eth2 client being the brain drives, and that simplifies this relationship between the software. We've actually, in the prototypes, there are prototypes of this unification of software and Eth1 existing as a shard today. In these prototypes, we have 4 RPC methods: block production, block validation, block insertion, and setting of the head. Produce block is similar to the get work RPC call, where on demand today in Eth1, where on demand you say, given all the transactions in your mempool and given your current state, give me a good looking block to build on this chain. Validate block is, I've got this shard block. I do some base validations on the system layer. For example, validate the proposer's signature and some other things. But then I say, hey, Eth1 client, can you actually validate this with respect to all the user layer rules? Can you actually execute the transactions here and see that things turn out valid? And if so, return true. Great. Insert block, this is kind of a variant on validate block. It's really like insert it into that local Eth1 block tree and update the state. And set head handles reorg. So the Eth2 client, being the controller of the consensus, understands when the shard chains reorg and need to be reorged. So when you need to update the internal state of what's going on in Eth1 and on that user layer, you can set the head there. Validate block can easily be modified to be stateless, and some of these methods can be stateless. And there might be additional methods that make sense to add. For example, the Eth2 client is aware of finality, and so it might tell the Eth1 engine that it's time to, you can prune these things. This has been finalized, so the Eth1 engine can be a little more proactive in pruning state and things like that. Okay, and so this work, this Eth1 Eth2 merger work, has largely been carried out thus far by Mikhail from TXRX at Consensus and Guillaume with the guest team at the EF. They've been driving these prototypes. It's pretty exciting to see these two pieces of software come together and to see that we can then, by keeping the user layer intact, we can leverage existing wallets, existing tooling to interact with that Eth1 shard. So for example, you can check it out. Mikhail has this out on Twitter. I'll repost it later today. But he has a video of demoing the Eth2 driving a multi-sharded consensus, there being an Eth1 shard, and sending transactions with MetaMask, unmodified MetaMask. Very cool. So the vision here is really to not to make extremely minimal modifications to that user layer in this migration and upgrade of the consensus. Got some cool stuff going on. Shout out to some of the Quilt team. It looks like they're going to get involved in this Eth1 Eth2 merger effort. Now that we have the base demo in place, there's plenty of work to do, a lot of fun to be had. And if this stuff interests you, like, please reach out. In the coming months, there's plenty of fun stuff to do on the development and the research side. So we're working on the proof of work, proof of stake, hot swap mechanics. So essentially, on the live Eth1 chain, how we can swap from proof of work to proof of stake safely. Looks like Mikhail's taking the lead on that and doing some R&D and prototyping. Validator deposits and withdrawals. Once you have the unification of the Eth1 chain with the beacon chain, we can handle validator deposits and withdrawals natively. There's some stuff to think through there, especially like on the withdrawals, push versus pull, who pays gas, that kind of stuff. Shard data fee market. At the initial merger, there will be one shard chain of state and execution. That's the Eth1 shard chain. But there will be many shard chains of layer 1 data. And we expect this to be very valuable to applications, especially in the rollups. We need to have a good way to pay for the data and essentially say, I want this data to get on chain. So working through those mechanics, opcodes additions and reform. Due to the new consensus mechanism of the beacon chain, there will be some system level opcodes that would be useful for user applications, namely checking what's going on with validators, or even especially looking into recent crosslinks from different shards so you can make proofs against data and do cool rollup stuff. And some opcode reform. There are opcodes that will need to be thought through once they move into this new consensus mechanism. For example, there is the proof of work difficulty opcode where you can peer into the chain and see what the difficulty is. It's not quite clear what meaning that should take on once we've moved to proof of stake. So we need to investigate some of the existing applications and usages and try to move forward with the minimally invasive path. So a lot going on. Again, if you're interested in this stuff, reach out. There's a lot of work to do and a lot of fun stuff to work on. So what about statelessness? One of the other major upgrade projects, and I mentioned this in the 1x stuff, to Ethereum, is this major upgrade to the user layer and to the state to move to stateless execution, stateless blocks, where essentially you don't have to have the entire state locally to process and follow the head of the Ethereum chain. Instead, bits of the state and proofs about them, called the witnesses, are included in blocks so that you can perform the execution without having a whole state. And this opens up it opens up a sustainable path to state management in Ethereum. In terms of where this fits into the Eth1 Eth2 merger, these things, because of the separation of layers, can both drive forward kind of unimpeded by each other. And there's not really a path dependency on one or the other. The merger can happen and then statelessness, or stateless can happen and then merger. So we're driving forward on both. And then when one's ready, we're going to do it. And when the other's ready, we're going to do it. In terms of the long-term implications of not moving to statefulness on Eth2, if we have statelessness, it opens up the opportunity to potentially have state and execution on multiple shards. If we don't have statelessness, we can't really open that up, because all of a sudden you're going to be putting the burden of not just one state, but the burden of many Ethereum states on all validators to be able to process and validate things. So statelessness does open up opportunities in how the consensus layer and the user layer together grow. But in the initial merge and the initial kind of immediate future, they're path independent. So what's the end game? I didn't know that Vitalik was going to post that excellent article on, I think it was the Magician's Forum this morning, about a roll-up centric map, but something that roll-up centric path for Ethereum. But this is something that I did want to talk to you a little bit about. In the beginning of an Eth1 Eth2 merge, we have state and execution on one shard. So we have Ethereum-like world on one shard, and we have a lot of data, a lot of L1 data coming from all of the other shards. We expect it, as I said, to be very valuable to rollups and to scaling in the immediate. And so we expect, rollups today on Ethereum and one shard might, one just Ethereum chain might provide a few orders of magnitude scaling. Then once you have 63 shards of data, you can get another couple of order of magnitudes of scaling. And so once we get to this merge place, we're going to have many, if we go down the path of rollups, we're going to have many orders of magnitude of scaling, which would probably be sufficient for a long time. So the question really becomes, we have one shard of state and execution and many shards of data availability and thus tons of scaling. Is it really worth, and this is a question, I don't know the answer, but is it really worth at that point adding additional L1 complexity to get another 10x, 100x in L1 scalability? The end game for me is to get to this Eth1 Eth2 merger and get to statelessness as soon as possible. And at the same time, to allow the rollup ecosystem to grow and to mature. I think at that point, we'll have a lot better information on how, if and how, to expand native execution beyond that initial one shard. And so the end game might look like one state and execution shard, many data availability shards, maybe a few state and execution shards and many data availability shards, or the full-blown state and execution everywhere. But we'll see. And I think the next 12 months, as the user layer, Eth1, develops, and as the consensus layer, Eth2, develops, and as L2 and the exciting rollouts develop, we're just going to, Ethereum's going to become better and better. A lot of awesome, cool stuff going on, and we're going to have better information on how to make good decisions beyond these initial developments. Whew. Cool. This is something near and dear to my heart. The merge of Eth1 Eth2 is, I think, one of the most important things going on right now. It's an exciting R&D project. Hit me up if you want to get involved. And again, if you didn't take anything else away from this talk, Eth1, Eth2, misnomers, false sequentiality. Instead, they are separation of layers. That's the better way to think about it. And it's really the most informed way that we can talk about upgrades here, talk about the different layers of the stack and the software. So thank you. I appreciate it. I'm sad that we could not get together this year at DevCon, but I am excited. One day, we will all hang out again together. Take care, everyone.
Danny, thank you so much for giving us an amazing overview. Looks like we have a few minutes before our next talk, and we got a handful of questions that people have asked on chat, so I'll just kind of ask them to you here, and we'll just relay them directly to you. So the first question we have is, I know you did a really great job at clarifying the separation of these layers, but if somebody holds ETH today, what do they have to do when ETH2 launches?
Right. So ETH2 is launching in phases. This is to iteratively manage the complexity. It's a major upgrade to the consensus. It's a modification. It's a major upgrade of the kind of the core economics of the system. So to do that safely, we're doing that in phases. What happens initially at phase 0 and what we expect to launch imminently is that we bootstrap this new system level chain called the beacon chain in isolation from existing Ethereum mainnet, meaning that proof of work module, that proof of work brain that's controlling Ethereum continues to control Ethereum for now. And then when we're ready for the merge, when we're ready for ETH1 to become a shard governed by ETH2, at that point, the existing state, the existing chain, at this point, before this point, it's going to be governed by proof of work, and proof of work miners are going to build the blocks. And then right after, the same state, the same execution is going to be built and governed by the proof of stake validators. And so in doing that, there's nothing you have to do. Applications will continue to run. Your Ether will continue to exist on this chain. Essentially, it's that swap. I called it a hot swap of the consensus from proof of work to proof of stake. So chill out, nothing to do. Unless you're a validator and you want to get involved early and kind of bootstrap this new consensus mechanism.
That's great. I think people are getting excited about hot swaps on the chat here for a live stream, and I know this is going to come up again, so maybe just I'll ask this and clarify this one more time. But if somebody is a dApp developer, do they have to do something special once Eth1 is merged into Eth2?
The intention is no. Because of the way that the state will continue uninterrupted, and because of the way that Eth1 clients will actually still be the interface into the user layer, the way that applications are built will be uninterrupted, will be the same, and the way that applications interface into that user layer, for example, how you send transactions, how a web interface might use Web3 libraries, that is uninterrupted because you use the same user layer APIs to interact with Eth1 once it's integrated into Eth2. Something important to note is that although things can continue uninterrupted, capabilities will expand. So we'll have this new sharded data availability layer, which first and foremost, we expect rollups to highly leverage and use for scalability. But having a scalable data availability layer is kind of a very new thing in decentralized protocols. And so we expect there to be a lot of innovation just with that in general. So keeping your eye and your ear to the ground on developments there and kind of expanding what Ethereum can do rather than like fundamentally changing the core is the goal here.
Awesome. And the last kind of two-part or two related questions are, how can somebody kind of keep up with what they have to do to stake for phase 0? Where can they find out more of the latest information? And then on that same note, for people who are interested in understanding how to keep up with what's happening with all of Eth2, what is like the best place they can go to stay up to date?
Yeah. So on the staking front, there's a testnet called Madasha, long-standing testnet that's up and stable. If you want to get involved, you can stake on that. We have another dress rehearsal testnet called Zinkin that will launch in about a week and a half. If you want to get involved in a Genesis event, which is kind of like one of the more interesting parts of staking, is really getting the chain up and running at the start. And then if you want to follow, I've been super excited about the ETH staker community. They started as a Reddit community and they have a Discord, and they're just like super supportive. Like, people are asking questions, people are answering questions, people are talking about hardware, people are talking about different software, security practices, all sorts of stuff. Check out, like, that should be the gateway. Go check out the ETH staker Reddit and the ETH staker Discord if you want to get involved. And the second question, sorry.
Just for everything Eth2 on research or implementation or
right.
progress updates, what is the best place to keep up to date on it?
So I do blog posts on the Ethereum blog every about 7 to 14 days, depending on what's going on. They're called Eth2 Quick Update. I try to keep you just informed on the little happenings. If that's not enough, then like, if you jump into ETH Staker, they're gonna, like, that is a great place to follow on the kind of staking side, what's going on. And if you want to dig a little bit deeper, there's the ETH Research Forum, and something that has been really exciting development and become really fruitful over the course of 2020 is the ETH R&D Discord, where there's all sorts of conversation talking about consensus, talking about, there's Tycho. Talking about consensus, talking about user, talking about Eth1, talking about Eth2, and really like technical fun discussions. It can probably be pretty intimidating at first, but like just lurk, see what's going on. You know, eventually you'll start figuring out what's going on and probably have something to contribute. So yeah, blog posts, ETH Staker, and ETH R&D.
This is great. I think your blog.ethereum.org posts are super helpful because they kind of condense it for every day. People just kind of understand what's going on without having their heads fully integrated in the technical pieces. And before we kind of end this,
one more.
Sorry, go ahead.
Ben Edgington does What's New in Eth2, and it's so good. Mine are like short little, like, I just say what's going on real quickly. He gives some like deep thought about what's going on in Eth2. So check out Ben Edgington too.
If I'm not mistaken, that is a Substack you can subscribe to. Is that correct?
Probably. I trust you.
We'll post it on the chat for
yes, it is. I forgot what that was.
Substack, yes, okay. One last question that we got from our YouTube chat before we move on to our next talk is, can you tell us what is the role or the features related to the BLS signatures in ETH2 and kind of what the significance of BLS is over there.
Yes. So we, in a sharded proof of stake model, we have to do random sampling to send parts of the validator set to different shards at any given time to essentially validate subsections of what's going on. And in doing so, we need a lot to make the random sampling safe. We need to have a ton of validators. So we expect, from the consensus perspective, for there to be like on the order of 100,000 of these little validator entities. Obviously, a user might run a few of them or even many more, but this helps with the random sampling. But because of this random sampling, because of how many validators we have tons of signatures. Like they're constantly saying like what they think is the state of the world. And so to do this efficiently and be able to verify and process everything efficiently, we heavily rely on BLS aggregation. So when people agree on something, which if they agree on the head of the canonical chain and the state of a shard, then we can aggregate their signatures. You can actually aggregate things that don't agree, but what we do is we aggregate signatures that agree, and then we bring that all on chain, and thus we have much smaller amounts of signatures to process. It's a great cryptographic technique. Obviously, there's like a lot of networking complexity and stuff that comes out of here, and like how we actually get all the signatures together and aggregate them. But that's a different layer of the stack. But BLS is awesome, aggregation is awesome, and it's been a really crucial feature to get this thing to work in a sharded context.
Awesome. Thank you so much, Danny. And for those of you who are interested in Ben's newsletter, it's actually eth2.news. That's the domain name. So you can just go there directly and stay up to date. So thanks again, Danny, for giving us a great overview of how all the Ethereum layers stack with respect to each other. And we can't wait for ETH2.